Welcome back. Here we have another example of a Fourier series. This is our fourth example. So, I have that so big. So we have, in this one, we have, our period is a little bit longer than the other ones, right? So the period for this one looks like it is 4. And the length is 2. So let's sketch the graph. So we have -1 from -2 to 0. -1. Okay, so that's going to be down here. And then we have 1 from 0 to 2. Interesting. See how we have this? So let's keep sketching. Let's do 2 periods. Here's 2 periods. Right. What the? 2 period. 2 periods. We're going to focus on this one over here. Looking at that section, we have odd symmetry, right? Thank God, right? Last 2 times we didn't have any symmetry. We have symmetry about the origin. Odd symmetry, right? So that tells us that we have a Fourier sine series. This is the best possible case, I believe. Yes, this is the best possible case that we want. Because if you take a look at this is the only term that we're going to be left with. You know how I know? Let's take a look. F of x is odd. We determined that. Integral of an odd function is 0. A sub n, this is odd. Cosine is even. Odd times an even is an odd. This is 0. Here we have an odd. Here we have a odd. Odd times odd is actually even. So we will have a b sub n. Okay, so we have to solve for b sub n. So that's the only term we have. We have our length was 2. 1 over 2 from -2 to 0. We have -1 times, so negative sign. I'll pull the negative out. N pi x over L. Actually, no, I won't. Just for clarity. Dx plus, excuse me, 1/2, 0 to L. This positive 1, yep. Sorry, that was bothering me. Dx. That's a 2, by the way. Okay, and our length is 2 in this problem, so plug those in. Let's integrate. This isn't too bad. This would be, integral sign is negative cosine, but we have the negative there, so that's positive. 2 over n pi x over 2 from -2 to 0 plus 1/2 times. This one would be negative. 2 over n pi cosine n pi x over L from 0 to 2. Let's start plugging in. Plug in 0, that's just 2 over n pi minus. Plug in negative 2. That 2 would cancel, but the negative inside just goes away because cosine is even, remember? So then we're just left with... Oh, sorry, wait. Minus 2 over n pi cosine of n pi plus 1/2 times, this would be negative 2 over n pi times cosine of n pi plus 2 over n pi. So you can see we have like the same thing, but opposite signs. Well, actually no, there's 2 of each, right? So it's actually technically, we combine these, oh yeah. We combine these together, it's just look at that. So then we'll just have, this becomes negative 1 to the n. Right, so now let's do our little test. If we can, we could leave it like this, but this one's easy to simplify, right? If n is even, a sub n is, let's see, oh sorry, this is b sub n. That's 1 minus 1, that's 0. If n odd, that's 1 plus, I'm sorry, 1 minus, yeah, 1 plus 1. So that's 4 over n pi. N odd, right? That's all we needed, right? Let's write out the solution. So for n odd, we had 4 over n pi what was I doing? Yeah, 4 over n pi. I did it a little differently in my notes, a little incorrectly, I would say. Times sine of n pi x over 2. Yes, that's it. That's literally it. But we have to rewrite it because we know that n is going to be equal to 2n minus 1 because it's odd. So let's write out the final solution. We can pull out that 4 over pi. This would be 1 over 2m minus 1 times sine of 2m minus 1 times pi x over 2. That could be rewritten, actually. I'm just looking at it. Do you see what I mean? Because you can write it as, might as well just do it quick. Right? Oh, sorry. And that's our final answer. That one was not too bad at all. We did that in less than 10 minutes. See, we love symmetry, right? Alright, I have one more example after this. Let's see what it's like. Once again, very nice symmetry involved. So, see you in the next video.